Okay, here is justify number 7. What is the remainder when 3 raised to the 333rd is divided by 10? So you can see this as 3 raised to the 333 over 10. Okay, and when I try to study this, I know that there is some pattern with 10. So I'm going to take a number and divide that by 10. And I realize that the number in the numerator, the ones digit in the numerator is always going to be the remainder. And that makes sense to me because 10 goes into a number and whatever is the remainder is going to live in the ones digit, because if it was divided by evenly, it would end up being a 0 there. So anything that's not 0 in the ones place is going to be the remainder. And I need to know this because I'm studying the remainder of this quotient. So then another thing is that this number in the numerator is super big. Okay, so I need to know more about this number. So what I do is I look for a pattern, maybe starting with a simpler example. So 3 raised to the 1, then 3 raised to the 2. So I'm building a pattern here, but I'm also looking at a simpler example, so it's more manageable. So 3 to the first power is 3. 3 to the second power is 9. 3 times 3. 3 raised to the third power is 3 times 3 times 3, which is 27. And I do that, and then I realize that I'm studying this ones digit because I know it's going to be the remainder. And when I do that, I look and I see the ones digit, and I notice that there begins a pattern. And so I look at this pattern, and it's 4 in the pattern, and it's in this particular order: 3, 9, 7, then 1. Okay, you can't go out of order. And so what I do is that then I realize that 333, if I divide that by 4 in the pattern, then I can figure out where 333 ends up in this pattern. And so it says 83.25. So I think, what does that mean? 83 is the number of cycles. So 1 cycle, 2 cycles, 3 cycles. And it takes 83 cycles plus another fourth of a cycle, because that's 0.25. So 1/4 would be at 3, because there's that fourth, right? This is the 1/4 of that cycle. And so the answer is